So far, we've learned how to add vectors, subtract vectors, and multiply vectors by scalars. In this video, we're going to learn how to multiply two vectors together. Ultimately, we'll see that there are two different ways we can multiply vectors together. The first is the dot product, which we'll review in this video, and the second is the cross product, which we'll review in a future video. So the dot product is often also referred to as the scalar product. Now, why is that? I just said that we're multiplying two vectors together. Well, that's because the dot product takes two vectors and gives you a scalar. So for instance, if we have vector A, you know it's a vector because it has that arrow on top, and we dot it, and this is the notation we'll use for the dot product. A dot some other vector B is going to equal some scalar C. So this is a scalar. This is vector A, vector B, and this dot is representing the dot product. All right, and we're going to really want to reserve this dot notation. I know sometimes people, they're multiplying 3 times 4. Sometimes people will put a dot in there to show that. We really want to, maybe you would use parentheses instead, like 3 times 4 instead of 3.4, because it'll be a little nicer if we try to reserve this dot for the dot product. Although you'll always know that it's the dot product and not something else because it should be sandwiched between two vectors. A and B are vectors. And the result of the dot product is a scalar. So the right-hand side of this doesn't have any information about direction anymore, right? A and B are vectors. They're objects that have direction. C, right, there's no arrow on top of this. This is just a scalar. It's just a number. It might have units, but it does not have any direction associated with this. All right, so there are going to be two ways to compute the dot product. And one is using components. So if you're given the vector components of A and B, and the other is using the magnitude and direction. Sorry, that's a little sloppy. That says direction. All right, so how could we compute it using components? Vector A dotted with vector B. This is equal to AX times BX plus AY times BY. And if the vectors are pointing out of the board in the Z direction, then you also have AZ times BZ. Now notice, as I said, the right-hand side is just going to be a number, right? This is a scalar. Why is that? Because components of vectors themselves are just scalars, right? A sub x is just telling you by how much A is going in the x direction. But the information that it is in the x direction comes with things like writing x hat, right? But AX itself, the x component, is just a scalar. So the right-hand side of this is just a scalar quantity. All right, and this is the formula for computing the dot product using components. Alternatively, we could compute A dot B if we're given their magnitudes and direction. And this is by A, this is the magnitude of A times the magnitude of B times cosine of theta, where theta is the angle between A and B. And what do I mean by that? If this is A and this is B, and I draw them such that their tails are together, then this is the angle between vectors A and B. All right, and you're always going to want it to take the small angle, not the long angle between them going the long way around, right? Theta is the small angle between vectors A and B. And so if you're given the directions of A and B, then you can determine this angle between them. And if you're given their magnitudes, then this will be the more convenient formula to use. Really, both of these should give you the right, or not should, will give you the right answer. And which formula you choose to use just depends on what information you're given. If you're given components, it's easier to use the component formula. If you're given magnitude and direction, go ahead and use that one. All right, so that is how to compute the dot or scalar product between two vectors.